Welcome to the JPS Product Briefing webcast. My name is Carol Hollingsworth. I am the Vice President of Sales. And of course, I'm with Iggy Bragato as always, the JPS Senior Solutions Engineer. In this episode, we will introduce you to the latest iteration of the Z-Series controller and its ability to establish complex wide area distributed communications. The Z-Series controller has recently gone through technological enhancements that has transformed an already remarkable wide area system management platform into an even more user-friendly orchestration tool that can ensure easy provisioning, deployment, and operations of complex distributed communication systems. Resourceful use of networks combined with the JPS audio Talkpaths and routing policies will ensure radio telephony, push-to-talk over cellular, and dispatch communications are treated as an agnostic and reliable manner to establish sharing between disparate communication systems, agencies, and orchestrations. At this time, let me introduce Iggy to you, and Iggy will provide you with a presentation and guide you through all of the new things and features and applications that this product can provide to you. Iggy?
Yeah, hey, thanks again, Carol. Yeah, it's pretty exciting. We're finally moving into the controller. I know we've spent a lot of time talking about the RSP-Z2 Dual Channel Gateway. We're actually going to talk about that again a little bit. But really want to kind of focus on wide area distributed communications and how we can leverage the power of the Z-Series controller and some of the new feature sets that we've just recently introduced. Yeah, and Carol, before we start talking about wide area distributed communications, I want to really start off talking about JPS RoIP. And as you can see in our little diagram here, I've got a couple third generation NXU-2B RoIP radio gateways that, as you can see, when we pair a LAN mobile radio or any four-wire device to, in this case, the NXU-2B, we can take that radio communications, we can compress it using codecs and vocoders, and then deliver that information over any TCP/IP network, and then I can deliver it to a far-end RoIP device where I can then recover the analog audio and then deliver it to another four-wire device or another radio. Hence, we're extending the radio coverage area by leveraging a network. And one thing that I always like describing JPS RoIP is we use a client-server association model, very similar to tin cans on a string. And it's really a very strong bond between these devices, but it is a peer-to-peer connection. Again, it's a self-healing connection and is a very radio-centric RoIP protocol that we've employed 1999-2000 with our first generation NXU-2A device. And some of the benefits of peer-to-peer JPS RoIP, primarily Unicast, is that it's very efficient. We create these peer-to-peer links between devices, very high fidelity, and as you know, we can apply, depending on the RoIP device, many different vocoders or codecs that allow us to compress the audio and efficiently deliver that information over a network. So it's kind of a nice way of balancing audio fidelity versus the available bandwidth or network bandwidth that I can utilize. So depending on the platform or the gateway, we can support 64 kilobit links all the way down to 6 kilobit links. So again, it's an efficient way of conserving my network bandwidth. Obviously, the JPS RoIP connectivity is self-healing, and that's important, especially if I have tactical operations. And again, we can support all types of JPS gateways, and that's one of the important aspects of the original JPS standard RoIP is that it exists in literally every product that JPS offers, and that's really kind of the bond that we can create with all these devices. So JPS RoIP is, again, very important. Yeah, Carol, as I mentioned earlier, JPS RoIP is important because a lot of our legacy gateways, and even our newer gateways, have the ability to implement our JPS standard RoIP. And we'll talk about other RoIP protocols as well. So if I want to create connectivity between some of our legacy devices like ACU-1000s or 2000s or ACU-Ms, they can interact with some of our newer products in our Z-class line of gateways. And as you can see, we can interact with third-party devices like push-to-talk over cellular. One of the characteristics of JPS RoIP in one of its configurations is it's unicast, meaning I cannot create a sort of a multicast or a many-to-one type of situation. As you can see here, we can only create that peer-to-peer connection. Depending on the gateway, JPS gateway, we do in some cases support multicast. And in the case of, for instance, NXUs, whether the first, second, or third generation NXUs, or even DSP modules, or ACU-Ms, ACU-Ts, ACU-5000s, they in some cases can support multicast networking. And what this allows us to do, we can take one device and distribute radio communications over what we call a multicast group. So we log into each one of these devices, provision them to be part of a multicast group. And this is a great way of creating a many-to-one situation, whereas unicast communications, it's a little bit more difficult. Maybe create two groups as we see here. I'll have to log into all these devices, reprovision the multicast group, and now I can have two different groups. If I want to change my landscape a little bit, and again, I'm going to have to log into these devices. And some of the issues that we see with multicast can be many. One of them could be human error, prone to mistakes, entering the incorrect information. It takes time. I can't provision these devices on the fly. If some of these devices are remote and I have difficult network accessibility to those devices, that might be problematic. So if I have a large wide area requirement where I have distributed gateways in my county or my state or nationwide, or for that matter worldwide, I might run into some issues in terms of sharing over RoIP. I could use a combination of unicast or multicast to create these complex wide area networks. And when the time comes and I have to reprovision my multicast group or my unicast associations, creating these associations on the fly could sometimes be difficult or problematic. So let's talk about the Z-Series controller. We liken this to a wide area system builder. It can create these very complex wide area systems of distributed gateways. And it's also a management hub where we can log into this device and control these remote assets and be more efficient with how we manage our assets. And really one of the big takeaways for me, now immediate and very dynamic control of these RoIP links. And we can control these links on the fly as opposed to individually logging into these devices and reprovisioning and creating, for instance, different unicast associations or multicast groups. So everything can be done on the fly. Some of the resources that we support, obviously radios are important. We got one of the most protocol agnostic interfaces on the market. We can support 4-wire devices, full duplex, high or low impedance. And we can also support standard-based protocols such as SIP or RTP, so we can support VoIP telephony. We can support JPS, our standard RoIP, JPS RoIP bridge protocols, as well as a feature set that we've just recently added called Unity. But we'll talk about Talkpaths here in a moment. And naturally, we can support a myriad of push-talk over cellular services. Some of the devices we support, I'm going to say this over and over again, because of the presence of JPS, our standard RoIP, we can connect to a lot of our legacy devices like ACU-1000s or 2000s, ACU-5000s, even ACU-Ms. Literally, the controller can support all our legacy devices, and naturally, moving forward, all our Z-Series gateways, such as the RSP-Z2 Dual Channel Gateway and the ACU-Z1. We can also take advantage of the ability to use secure browser-based user interfaces as opposed to software. So what this allows is provide accessibility to the hardware from literally any location, regardless of the platform. I can control this system using a PC, a Mac, an Android tablet, an iOS tablet, even my smartphone, for instance. So that's a great advantage in terms of remote control. So I can use any modern browser to control this system as well. All right, so if I'm going to develop or build a wide area distributed system with distributed gateways. And remember, we talked about this in the past with RSP-Z2s. One of the advantages of using low capacity gateways like RSP-Z2s or even NXUs is that we can move those gateways into radio coverage paired with their donor radios. But with the advent of the Z-Series controller and the Unity feature set, we can now manage these distributed assets more reliably. So as you can see in the diagram here, illustrated in blue, which depicts JPS RoIP links. These are definitive links back to the controller. And we also have what we call the Talkpaths in red. And Talkpaths can contain lots of information, liken them to a trunk. So if I look at an RSP-Z2, that RSP-Z2 could support maybe 2 radios, could support a SIP connection, might support a push-to-talk of a cellular talk group. With the presence of a Talkpath, I can create this trunk where all that information is flowing through the Talkpath, not consuming any more bandwidth than I need to. We can actually even throttle that bandwidth down to 13 kilobits using a global system mobile codec or even a 64 kilobit codec. Talkpaths function much more efficiently than RoIP in terms of the ability to handle lots of radio and telephony communications in a single trunk, for instance. And we're going to spend a lot of time on Talkpaths and the Unity feature set or the Unity suite, which allows us better management of remote devices out in the field. Yeah, and one of those feature sets within that Unity suite is we can create routing policies over these Talkpaths. Primarily with our Z-Series devices like the ACU-Z1 and RSP-Z2. And what a routing policy does, it allows us to manage how the RoIP is shared over the network. And here's an example of a routing policy called Always Use Hub. If I look at that Z-Series controller on the bottom left, that's acting as a hub. And as you can visualize that being a hub on a bicycle wheel, we can see the RoIP spokes associating to the remote gateways. And in this routing policy, we can take the RoIP information through our definitive RoIP links or through JPS Talkpaths and deliver that information in the form of RoIP to the Z-Series controller. We can take that information into the digital audio mixer of that Z-Series controller. So you and I as users of the system, we can then direct the controller to then reshare that information back out to remote gateways out in my operational area. The other routing policies that we can instate in the Z-Series controller, one of them is called distributed routing policy. And as you can see in the illustration here, you can notice that some of these RSP-Z2s do not have that definitive link back to the controller itself. Depending on your network capabilities, you can share the JPS Talkpaths directly between the Z-Series gateways, and this adds a lot of efficiency as opposed to sending Talkpath back to the Z-Series controller. We can allow these remote gateways to then more efficiently share radio or telephony communications or push-to-talk over cellular information out at the edge. But then this gives us a lot of efficiency in terms of how we share radio and telephony communications. But I believe one of the biggest benefits of the distributed routing policy is that in the advent of an isolated controller, regardless of maybe we have a power outage or the network around the controller goes away, if I have a number of my Z-Series gateways functioning under a distributed routing policy, that RoIP continues to flow even without the presence of the controller. And naturally, if I bring the controller back in the picture, maybe restore power or maybe the network around the controller, all my other peer-to-peer links from my legacy devices, for instance, will then be reestablished automatically. Remember, these RoIP bonds are very strong. One of the great advantages of using the Unity feature set in the Z-Series controller is actually the ability to recover or maintain communications even without the presence of the controller or that management hub. So the nice thing about the routing policies under the Unity feature set is we have the ability to select that routing policy. Depending on the capabilities of my network, I might not want to use a distributed type of routing policy. A good example is out at the edge, I might have an RSP-Z2 being supported by not only LTE, but maybe SATCOM. I'm load balancing between those different network transport means. But the nice thing about the routing policy, I can set the routing policy differently between these different gateways depending on the capabilities of my network. So it gives you all that flexibility under Unity. And so this is an image of the Z-Series controller, the user interface, and we've seen a little bit of this in the past during our RSP-Z2 discussions. We naturally looked at the user interface, the browser-based secure user interface. We are using common modern day browsers to log into the hardware. We're not logging into servers, but we log directly into the hardware. It gives us a lot of reliability, but one of the advantages is I don't have to distribute client-based software. So incidentally, the controller can support as much as 160 RSP-Z2 gateways. That's pretty astounding. We're talking over 600 resources can be supported by a single controller. And again, this is because of the power of the Unity suite of functionality in terms of allowing us to create these very complex wide area systems. And just kind of as a reminder to everybody, Carol, here's a view of the capabilities of the RSP-Z2. Very capable gateway by itself, but when introduced under Unity, we can create some very complex wide area solutions. So back to the user interface, again, we can also support our legacy devices using other digital protocols such as our JPS standard RoIP, bridge protocols. And so this allows our legacy devices to interact. And so if you see the column on the left, the tiles at the top, we call those local resources. The tiles at the bottom are our remote resources, which are typically our Z-Series devices being managed by the Unity feature set. And you can see our MCC 12, it's a 12-channel hardware-based console. And as you can notice down there on the bottom left, our stack of RSP-Z2s, they could also be hosting a JPS MCC console as well. And the benefit of that is distributed communication. So in the advent, if I lose my controller because of a power failure or the network goes away, some of these consoles can still continue communicating with these remote gateway. So lots of redundancy can be created by using remote assets or even local assets inside the controller. Same holds true for VoIP or SIP. We can assign tiles that register with your SIP proxy server, and we can then assign those tiles with a telephone extension number. And they can also exist at the RSP-Z2 level. And again, we can do the very same thing with push-to-talk of a cellular. Push-to-talk of a cellular can be very dynamic. We can move those push-to-talk of a cellular talk groups into different interoperable domains, so we can be very dynamic in terms of how we share push-to-talk of a cellular services.
So, Iggy, we have all the push-to-talk over cellular resources already embedded in our products. We're continuing to add to that list. I would anticipate in the next year that it's maybe 6 or 7 or more will be added to that as we move forward. I think that one of the things that is easy for our customers is when they purchase these products is being able to upgrade as we make upgrades. And all of those are on the website. They're easily downloadable. And we'll make sure that notices are sent to all of our customers as these upgrades are completed.
For those customers that have not updated to at least version 4, you're missing out on a lot of these awesome features. For instance, that Unity feature set, which again is really kind of the key or the heart to wide area distributed communication. So do that update. And you're right, Carol. There's lots of push-to-talk over cellular services jumping on board with us because of our efficient processes that we employ in our Z-Series devices. So you're right, Carol. Look into the future because there's going to be a lot more push-to-talk over cellular services directly supported in our devices as well.
Yeah, we don't want our customers to think that when we have a firmware upgrade that it's simply a fix. It's much more than that. In most cases, it includes so many new features and that they actually really do need. So it's important to upgrade those for many reasons as they become available.
And you're right, Carol. Engineering is always surprising us with some of these new functions and some of the features that a lot of our customers and dealers request. We actually incorporate that into these devices. So I believe we need to wrap this up. But what I want to do, actually, Carol, is show you kind of the user interface. And this is an example of the user interface of a controller. We're creating separate interoperable domains where all these different resources could communicate back and forth. We can also create a monitoring domain where we can take unselect audio and deliver it to a destination. In this case, it might be a PTT button on a JPS MCC console, and we can create as many nets as we have resources that you see listed on the left. Again, RSP-Z2s and ACU-Z1s will be on the bottom left, and the local resources will be up on the upper left column. And as you can see on the top, we did create a dispatch net. And dispatch nets are pretty interesting because they are based on user login. So if I have another operator logging in on a different browser-based platform, they can have their own dispatch panel. So we'll talk about that in a future Z-Series controller episode, and hopefully kind of reveal some of our new features that are coming out. I think that's it, Carol. And again, I want to tease what we're going to talk about next episode, and that will be primarily on the Unity feature set, which is the ability to create these larger wide area distributed systems. We're going to talk about discovery mode, how we create this bond, and how we can make simple provisioning or include these remote gateways into this environment very simply, as opposed to creating these separate RoIP links. We can actually create that trunk that I mentioned earlier, which is the Talkpath. And so that's one thing I want to really focus on. We should focus on next time, Carol, is talk about Unity specifically.
I agree. I think that we've shown today that the Z-Series controller is an integral part of our Z-Series of products. It's one of those that has so many applications that can apply to different markets, different industries. It's becoming more and more important to any type of a system of systems, or especially as we're going to talk about the wide area system builder. It's important to our viewers today to attend the next one, because this is only going to add to what you have presented today. We do want to thank everyone for being with us today. We really appreciate your joining us, and we want to remind you to visit the JPS Interop channel, and we want to thank you so very much for being with us and being a JPS customer. Thank you.
All right. See you next time.